All right, so we still got to talk about specialty cabinets and some of those items here. So I have a small list of those I want to go through with you here. Let me find that. Oh, there it is right there. Okay, so specifically, I want to look at these four items. We're going to look at vanity cabinets, tall cabinets, microwave cabinets, and open cabinets. So um, those we can pull up examples of. I don't have a specific drawing that's going to really showcase those that we can work on together, but I can probably find some older examples of different ones that I can look at with you so we can at least get an idea of what those look like. Um, so I recently just did a project for some vanities in a restroom. I'm going to pull up the drawing for that. I'll look at that with you here. So let me see if I can find that here. All right, I'm going to start with this one. All right. So starting with vanities here. Um, Vanities can be a little on the complicated side for something that looks pretty simple. They're really not too bad though. A couple things I want to look at with you are going to mainly be focused on the section view and then the steel support that goes into the section view of vanities. So right now from the top-down view, it looks pretty basic. Like you're looking at a countertop with side splashes, a backsplash, and a couple sinks thrown in there. What is going to be a little bit more in depth is when you get to things like the section view, elevation view. It's not too bad either. These do fold up towards the underside of the counter. And so this is your elevation view here, of course. Down here, this is all drywall by others down here. The cabinets kind of float underneath of that countertop. And they are at an angle here specifically designed for ADA access to get wheelchairs underneath of this countertop. So one of the things that we're going to be really paying attention to as we draw something like this is we really need to make sure that we are following ADA guidelines. So I'm going to pull up the ADA vanity clearance website and show you what those requirements are so that way you have a better idea of what this needs to look like. This is accessboard.gov/ADA/guides/chapter 6 lavatory sinks. So this kind of explains the gist of what the ADA or Americans with Disabilities Act requires for different wheelchair access points, specifically aimed at lavatories, sinks, vanities, you name it. So one of the things that we want to look at is this graphic down here. This is really going to be what's important for you. This is your vanity clearance graphic. So what I'm going to do is probably just add this to the notes that I have set up in the training folder for you. This is a very, very useful graphic. So what we're seeing here is the yellow is the space that you need for a wheelchair to be able to access these under counter areas. Anything in tan, like over here, this is going to be the outline of the vanity that we're going to be building. So like this is the front face of that vanity, the screen that we were just seeing over here. Whoops, let me try to split screen this if I can find it again. Aha, there it is right there. All right, so, hey, I can take care of it. If you want to drop them off, I can get them put up on the shelves and all that. Oh, well, they're going to go on the left side over there, up on those shelves, but they're kind of heavy too, so yeah. Yeah, we can work through them in a little bit. If you want to just leave them, that's all right. Yeah. Thanks, Ben. All right. So vanities, this is that graphic here. I'm going to add to your notebook here for you. Um, as you can see on the section view for this K1 drawing that I have here, you can see this dash line what I did was I drew a polyline in AutoCAD, or a P-line, and I kind of just traced out these dimensions that are provided here in order for me to show, and that gray line kind of goes, you can kind of see it if you zoom in close enough, it goes all the way across the front of that vanity and down to where the toe cake would be right there. Because our vanities are floating, this dimension here actually doesn't really pertain to us, but we do want to make sure that we have this 9-inch floating piece here. So like our vanity shouldn't be touching the floor. It should be 9 inches off of that floor like that. Now, they don't exactly give you the degree of which this is angled, but they give you the dimensions you would need to find that degree. So you have 18 inches up from that 9-inch mark, 18 inches up to there, which I kind of show right here. So from the bottom of that vanity door to the underside of the apron is 18 inches. That would be underside of apron here. And then they require 8 inches minimum from the angled portion to the front edge of your counter. So on my drawing here, front edge of my counter protrudes out an inch past the apron, and so that 8-inch mark actually goes all the way out to here. So again, this is to be in line with the edge of that countertop. So that's where that 8-inch stops. Other things to take note of too is that with ADA guidelines, you do need to make sure this is 27 inches from floor to underside of the apron. There can't be any obstructions between there and there. Otherwise, it will break ADA code and it actually won't pass an inspection. So that's where the dimensions on here become really important. It can be a little bit stressful thinking about it, but it really isn't that bad. You just got to make sure that you do follow these dimensions here on this graphic and you will be just fine. Some things to also take note of other than the dimensions is that you have this bracket here, which we talked about in the cabinet hardware video a while back. This is hardware's 9 and hardware 10. Hardware 9 and 10, which is the Aventos HK system. It's a specific type of bracket that unfolds, and this door would kind of move in this direction here. So this is your door on the hinge piece. Whoops, sorry. It kind of goes like this. So it folds out like that, which allows the plumber to get in here and do any of the install or adjustments in the plumbing for the sink, but also makes it so this panel doesn't have to be removed from the cabinet in order to do that, have access to the plumbing. That seems to be the best method of approach that we've come up with at Onsite here as far as keeping everything together. We used to use a detachable panel that you could pop off of this and set aside while you work on the plumbing, but we were having issues where the panels would get knocked over or damaged or misplaced. And so nowadays what we do is we use this type of hardware to keep these panels attached to the vanity even when they're being worked on. So they can't get misplaced, they can't get knocked over or dinged up, so they stay attached to the actual cabinet itself. Something else that's a little bit unusual that we haven't really looked at yet is we have not talked about in-wall brackets. Now, vanities, you're going to see a few different styles of those. Let me just make sure we don't have an actual quality sketch of a vanity first. Let's see, drawings. Let me look that up real quick first. All right. So it does not look like we do, which is fine. We'll probably get one in here eventually. But what we're going to do is with the steel support. So there are a few different things you got to look at with vanities. So you're always going to need steel support in a vanity, no matter what. Sometimes you'll have a vanity that has no wall or walls on the sides of it. If you don't have any steel support over here, or sorry, if you don't have any wall over here on your vanity, so let's say this was not here, and the side splash wouldn't be there either, just for example. If this vanity was open to the room on this side, we wouldn't be able to use this detail here. This detail here is a steel bracket that we have made. which also goes from wall to wall. So you can see here's a little axial view of that. It's a metal angle with a steel plate welded to the left and the right. That steel plate will actually bolt into the wall on the left and right of the vanity, and it has these screw holes here to attach to the back side of that apron like that, and underside of the counter. So it helps keep that all supported. Now, that only works if your vanity is going wall to wall. So like this one here, for example, that would be just fine. We could use that bracket all day long, no big deal. The other thing is too, if your vanity goes wall to wall, but the span is larger than 10 feet or 120 inches, you actually won't want to use this detail. It's not really designed to support the weight of a counter on a span of like 10 feet long or greater. So what we're going to do, if you do have a vanity like this, let me pull up the CAD file and I could show you an example of what that would look like. If you have a vanity like this, and it spans a opening greater than 120 inches, we need to supply in-wall brackets. So that's really easy. I'll show you what that looks like. So we haven't really gotten into that yet. I just got to pull up the CAD for that drawing here. Here we go, K1. And we'll talk about that here real quick. When AutoCAD decides to, there it goes, decides to load. So yeah, just mental note to keep track of for later when you're doing vanities. Like if it does not go wall to wall, you need in-wall brackets. If it goes wall to wall and it's greater than 120 inches wide, you will need in-wall brackets. If it's going wall to wall and it's less than 120 inches, then you can use this detail here, which is a custom built steel bracket that we utilize a lot for these types of vanities. Let me pull up my CAD file here. Got it. Okay. So let's look at this section view here. So right now, this section view is utilizing a steel bracket like the one we did see on our print. So this guy here. Once we determine whether or not we need in-wall brackets, if this detail is not sufficient and we need to use an in-wall bracket, what we will do is we'll go into our on-site tool palettes under the hardware section. And the in-wall brackets that you're going to use for all floating counters, all vanities, are going to be in the brackets tab up here. And that'll be the A&M EC or EC flats. So we're going to grab one of those. A&M EC, that's what they look like. If you wanted to see an actual picture of one, I'll pull that up too. So you can kind of get a good idea of what this really looks like in person. Okay, so there's a image of one there. There's a EC bracket, which stands for extended concealed, meaning that it has this vertical piece at the top and the bottom. You also have just the standard C bracket or C flat here in this case, which has the bracket at the bottom that attaches to the studs in the wall, but nothing up top. And then they make these other brackets too for exceptionally deep counters. They are called the, instead of the EC or the C flat, what that would be is that would be the, going back to it here, that would be this guy, which comes in the extended concealed or EC or standard C bracket, but this one has an extra metal angle attached to the arm, so that way it has a little bit more support to it. We do use those, but we use them on longer counters, like counters that are spanning like over 24 inches deep. We'll want to use something like that typically because it'll keep that countertop from flexing at all as you put weight on it. Okay, so going back to our example though, we're assuming this countertop does not go wall to wall or it goes more than 120 inches long. If that's the case, what I'm doing right now is putting this bracket in. So right now this bracket's a little short. General rule of thumb here with your in-wall brackets is you want to make sure that your in-wall bracket at least covers 2/3 of your countertop. Anything less than that, and that countertop will be a little flimsy. You want to make sure that you're at least covering 2/3. So we may be able to use the EC flat 21-inch bracket. We usually don't use that. It says do not use because it has more of a tendency to be a little bouncy there, but it's going to help either way. You can use that, or you could use the standard EC bracket, which is also right here too. The difference with the EC bracket is more of the cabinet will have to be notched around this T shape, this guy here. So sometimes they don't like to use them because of that. But anyway, yeah, general rule, when you're dealing with an in-wall bracket, you want to make sure that it actually covers at least 2/3 of your countertop depth. Anything more than that or anything less than that, it'll be a little bit flimsy, a little bit unstable. So try to make sure that you're at least covering 2/3 of that counter. Other thing you may have noticed too is that I have this bracket in here. It's actually not in line with the face of the drywall here. It's actually set back 5/8 of an inch. 5/8 is your standard drywall thickness. So we'll set that bracket inside of the wall, which will sit right behind the back of the drywall, and it will actually bolt into the metal studs in the wall. So again, that detail is used only when you have a vanity that does not go wall to wall, or the vanity is more than 120 inches long. So that's in-wall brackets. These actually get used for things like floating counters too. So imagine you didn't have the sink here and you didn't have the vanity screen. You just had the countertop in the bracket. That would be kind of like along the lines of what a floating counter is going to look like. I'll just kind of show you what that would be real quick. It'd be more like that. So your floating counter, which I didn't grab the bracket too. Whoops, one sec. Yeah, so if you have a floating counter, it's going to kind of look something like this here, like that. And in that case, you would still put an in-wall bracket in to keep the weight of that counter from falling down. It also gives it support to make sure, it has enough support to stay up like that. So anyway, that's kind of like around the lines of what a in-wall bracket looks like for a floating counter as well as a vanity there. So yep, that's kind of vanities in a nutshell. I'm going to go ahead and add that graphic though to that document that I have for you. And then we will move on to, let's see, I'm going to look at open cabs next. Open cabs are going to be the next easiest thing on there. So let me throw that in your notes real quick, and then I will go on to that. There we go. Now I'm waiting on Word. All right, need a page break. And I need to paste that in. Cool. Whoop. Okay, that's in those notes now. I'm going to save that there. Cool. Okay. Now going back to it, we're going to talk about open cabinets next. So moving on down the line here, I'm going to copy this wall hatch over, and we'll talk about what an open cabinet entails. So open cabinets are pretty easy. All that really means is that your cabinet doesn't have a door or a drawer front on it. It's just open to the inside. We probably have those in both offices here in Austell as well as Loves Park. But from the elevation side, an open cabinet, like an open base cabinet, is just going to look like, hold on, it's loading. There we go. It's going to kind of just look like this. So basically just a cabinet without doors. All right, when you get to the section view of an open base cabinet, what you want to do is you actually want to modify that section a little bit, because our base cabinets generally have what's called like split rails at the top. So you have a back rail and a front rail. But when you're dealing with an open cabinet, it is easier for the customer to be able to see this portion of it. So there's no doors covering that up. So what we actually need to do when we draw one of these types of cabinets is we actually need to adjust the top to have a full rail. So what it's going to be is it's going to go all the way front to back. So kind of like this. Okay. So an open cabinet does require you to have a full top on there, which is going to be the next segue into the tall cabinets too. And also one other note to add to your notes here for open cabinets is that if you're, well, okay, so we've talked about how most cabinets are going to have either white melamine or black melamine interiors. That's pretty common. If you have an open cabinet though, those are special. They actually will require the outside finish to be on the inside too. So if your cabinet's for PL4 on the outside, your open cabinet actually has to have PL4 on the inside too, because you are able to see that since there are no doors covering it up. So open cabs won't receive black melamine or white melamine. They'll actually receive whatever the outside finish of the cabinet is. Okay. All right. Which then we're going to go into tall cabinets next. So tall cabinets have some special notes as well. So let's say you have an architect that wants a cabinet that has, let me pull these notes up real quick here. Let's say you have an architect that is requesting a really tall cabinet that has wide and tall doors. Okay, so one thing that we need to look at is that with cabinets, there is a maximum cabinet door size from AWI standards. They actually require that cabinet doors should not exceed 24 inches wide, and we're talking about the doors and not the actual cabinet carcass itself. The door should not exceed 24 inches wide, and it should not be taller than 84 inches tall. Anything taller than that is going to eventually warp over time. It's just kind of inevitable. We'll do as much as we can to prevent that from happening, but if you have a cabinet door that is taller than taller than 84 inches and wider than 24 inches, or one or the other, you'll want to add this note to your drawing somewhere below the view that it pertains to let the architect know that there is a potential issue with those doors becoming warped over time. So there are other notes here too, like maximum and minimum cabinet depths that are worth looking at as well. So according to AWI, your cabinet depth should not be smaller than 22 inches deep, but your cabinet depth should not be larger than 30 inches deep. So they do have limits on that too, just to take note of that. All right. Other notes. So this one actually pertains to tall cabinets. So we have cabinets that are over 72 inches in height. And if that cabinet does not butt into or touch a drywall wall or another cabinet at both ends, it actually does require it to have a 1-inch thick fixed shelf in the middle at approximate mid-height. So what that does is it keeps that cabinet from what's called racking. So as you transport it or you move it, or even as it's just sitting there in the field, it's going to be less likely to want to sort of flex left or right because it has that fixed shelf, which helps keep it rigid. Again, that's for cabinets that are over 72 inches tall. We want to make sure that we catch that on drawings going forward. All right. And then here's another little side note for you too. If you have a cabinet that's over 42 inches wide, you're going to want to make sure that you have a 1-inch thick, um, 1-inch thick shelf in that cabinet. Big shelves are wide cabinets. I don't think it has to be fixed, but it does need to have a 1-inch thick fixed shelf there. So just take note of that too, or sorry, 1-inch thick shelf in a cabinet that is over 42 inches in width. If you were to put a 3/4 inch thick shelf in a cabinet that's over 42 inches wide, that shelf eventually will sag or start to bow in the middle. And you want to try to avoid that by using a thicker core material. So in this case, we would use a 1-inch thick core material instead of a 3/4 thick for that particular shelf. There's also notes on here about those gaps too, like top gaps, side gaps, all that stuff. We've kind of talked about the majority of these. There's your note about your open cabinets there, 5-inch wide at front and back for the front and back rails. And then if you have an open cabinet, it has to receive a full top on it. All that stuff's just kind of generic standards that we have. All right, let's go back to our tall cabinet. So again, if you have a tall cabinet on a drawing, let's say I was to drop in a 2-door base cabinet, but it's over that 84 inches tall. So let's say this is going to be, I don't know, 108 inches tall, just for fun. I don't know why it would be. Well, maybe we'll make it 96. That'll be more realistic. So 8 feet tall. And we'll make it 49 inches wide because that would technically be, the cabinet doors would be more than 24 inches at that point. If you did have a drawing with that on it, you want to put this note below that view. So what we'll do is we'll do like mtex, and we put that note down here. You can either just copy it, or if you have it, you can type it out. Ooh, all right. Sorry. That came in at a really weird scale. I'm going to fix that real quick. Anyway, that note is in the AWI book. It's also something we want to take note of, though, too, because it's something that is going to matter when it comes to drawing cabinets. So making sure that your cabinet doesn't exceed those dimensions is going to be really critical. If you happen to see a cabinet that's bigger than that, 9 times out of 10, you're probably going to see a little bit of warping going on in the door. So again, we'll put that note there if your cabinet is larger than the AWI regulations on that door. Okay. One other side note about tall cabinets is, much like open cabinets, they also need to have a full top on them too. So this can't have a front and a back rail. It needs to have one full top all the way across from front to back. That's because if you open the doors on here, the person standing here at the front is going to be able to see the drywall ceiling above these cabinets, or if it's unfinished, they're going to see right up there if there is no full top on there. So it's really important that we put a full top on these tall cabinets like this. All right, moving on. Let's talk about microwave cabinets next. So I'm going to pull from a job that's already in the system. Let me see if I can find one here. I believe here, I think what I'm going to do is use SharePoint and pull up a drawing from a recent project. Let's see, that would be, I think Truist Battery had a bunch of these, so we're going to look for one of them here. Okay, so the way that we build microwave cabinets, it's kind of like having a cabinet with a false front or a fixed front on it. Let me find a drawing that shows one. I think the L1. No, not L1. It wouldn't have been that. Gotta find a break room. Those are gonna have those, or maybe social gathering would have that. Aha. Okay, cool, perfect. So what you're seeing here from the front view, so you have microwaves over here on the right-hand side of the elevation, and you have a tall cabinet. So this cabinet goes from floor pretty much to ceiling. There is a 3/4 inch reveal at the top, like we've been doing on our cabinets. But if you notice in the middle, there's a microwave section. So there's two shelves or two microwaves that are being mounted there. You go down to here in the section view, and I'm going to try to, well, I guess I don't have to zoom out too far, but you can kind of see what's happening. So there's outlets mounted in the back of that cabinet, just like that. And then the front of the cabinet, instead of using hinges to attach that cabinet door like this, what we're actually using is the Hardware 24 button fix that we use for the trash can tops. So what that is a hardware that allows you to kind of click together pieces of material and they stay attached unless you want to unclick them and take them off. So it makes it easy to remove if you have to do anything with it. So if you have to get in there to clean, access whatever's in there, wiring, what have you, you can pop that off and get in there. A lot of times microwaves will also come with what's called a trim kit. And when they have a trim kit, what we do is we like to have this panel here specifically for that, because we'll have this panel sent to the field as one full panel without any cutouts in it. And then in the field, the installers will actually take the template from the equipment that's out there, cut out the opening for the microwave, and then the trim kit gets attached to the front of the microwave. So let me try to find a microwave with a trim kit so you can kind of see what that looks like. This one has one here on Lowe's website. So you have the actual microwave itself, and then you have this border piece that goes around it. And a lot of times architects will specify one of those because it helps with hiding like any gaps between the microwave and the cabinet. And these tend to be pretty complicated to coordinate with, so we do try to make sure that that trim kit fits over top of the panel, like what we are seeing here. So we want to make sure that that trim kit doesn't overhang past the cabinet or anything like that. But the nice thing about this, though, is that we don't have to have the exact cutout size perfect. We'll still dimension it and write VWE on there, just so that way we have dimensions to it. And so the architect and the install team can verify those and make sure that that's correct before they cut those. But yeah, the trim kit will stick out in front of that panel. So the microwave kind of just sits there. Trim kit will be out here in front of that. And the cutouts will be done in the field typically, which is why that panel is removable to make it easier to detach it, make the cutouts, reattach it to the cabinet, and then they're good to go. So those are some specialty cabinets that we're going to have to use at some point down the road. You may not have seen those yet, and you may not see them for a while, but they will show up at some point. So I wanted to give you at least a little preview as to what's coming later. I'm trying to think if there's any other specialty cabinets that you may see. I think for right now, that's probably about it. But if we run into any other ones, please feel free to give me a call or talk with one of our listers, and they'll work with you on this too, as far as trying to figure out how to build one of these types of cabinets if you run into something that's weird or not normal, not a block.